Good morning, everyone. In this presentation, I'm going to talk about a study that we did a few years ago, and we developed a fine-level measure of accessibility for St. Louis metropolitan area. We are East-West Gateway Council of Governments, the Metropolitan Planning Organization for St. Louis region. So a little bit about St. Louis region. It's the 21st largest metro area in the United States. It has a population of about 2.6 million. It is located in Midwest. And as you see on the map, the distance between the eastern and western boundaries of the region is about 160 kilometers, which means it's a fairly large region. St. Louis is a blend of social problems. It has the highest crime rate in the United States. The low-income population in some neighborhoods is about 60%. And in some neighborhoods, we have 20% of households not having a car. And I understand that that number is not high in European countries, but in the United States specifically, where the cities are spread out, where the access to transit is not good, 20% of households not having a car usually translates into 20% of the population not having access to jobs, not having access to education and other opportunities. So this all means that St. Louis region is a strategic location to look at the issue of accessibility in the United States. So commonly in literature and practice, traffic analysis zones, block groups, and neighborhoods are chosen as the unit of analysis. And one problem is that such units are large. If you look at, for example, in this map, the red lines represent the TAZ or traffic analysis zone boundaries. And if we're doing a study and if we're calculating the accessibility measure for a region, and we're looking at accessibility to bus stops that are represented here with green circles. And if our unit of analysis is a TAZ, we're assuming that all the population that is living in a TAZ has the same level of access. But that's not the case here. For example, a person who is living at point A has a much better access compared to a person that is in point B. So what can we do? One thing we can do is to choose a finer level of analysis or unit of analysis, and that's exactly what we did in our study. We used census blocks as our unit of analysis that are the census blocks are represented with yellow lines in this picture. And census blocks are, in the United States, they are the smallest geography for which census data is publicly available for. So how did we measure accessibility for each block? We calculated travel time and travel distance from the centroid of each unit of analysis or each block to each point of interest. And point of interest in our study, we categorized them as education, entertainment, and recreation, food and drink, and etc. They're basically destinations that people travel to. So after calculating travel time and distance from each block to our points of interest, we defined an accessibility score. And the accessibility score that we defined was a function of number and distance and type of points that were accessible. So the form of function is arbitrary. You can choose whatever function that you like, but the point is having a uniform measure with which we can compare the blocks over the region in terms of their accessibility. So how did we do this in our study? So for each block, we defined a catchment area, which was a circle with a radius of 3.2 kilometers for walking, and 30 minutes for transit. And within the block's catchment area, we looked at all the points that were accessible. For example, here for Block A, for the catchment area of Block A, we looked at the points of interest that were accessible. For example, we had a school that was accessible within a quarter kilometer. We had another school, we had a park, we had a hospital and a library. And then using this information, we measured the accessibility, or we defined an accessibility score for that block. We used, for example, a weighted sum. As I said, this could be an arbitrary function. This is could be something that you like, but we used weighted sum, and the weight was a function of the distance of a point and the importance of it. And we choose our weights in a way that a block, the maximum score for a block was 100. So after calculating the accessibility score for each block, we plotted it on a map. And this map here, for example, represents the walking accessibility score over our region, and different colors represent different levels of access. No colors mean no zero or almost zero access, and blue means high access. And as you see, for the most of the region, the walking accessibility score is very low, whereas in core urban areas, we have higher level of access. The same way, we calculated accessibility score for transit. And as you see, using blocks as the unit of analysis gave us the ability to look at the accessibility in a very fine detail, something that we could not get if we had used larger units of analysis. Like, we can look at the hot spots where there's no access. We can, in this way, we can look at the environmental justice focused groups, low-income population, minorities, see what is the level of accessibility, exactly where they live. Like in this map also is a similar study that we did, but we used TAZs as the unit of analysis. As you see in this map, you cannot get the level of detail that we got when we use blocks as the unit of analysis. That was basically the contribution of this paper or this study. So if we use blocks as a unit of analysis, of course, it gives us more accurate results, but we would also face calculation difficulties. For example, in our case, we had 70,000 blocks and 18,000 points of interest, and calculating travel time or distance from each block to each point of interest in our region meant performing about 1.3 billion calculations. And during that time, the only commercial software that we were aware that could handle such a large number of calculations was Basemap Track. And we used that software to perform our calculations. To give you a summary of the workflow, the track calculated travel time and distances between the centroid of each block and each point of interest, and stored the results in a SQL database or in a CSV file. Then we wrote a Python code that could obtain the stored travel times and distances. And then the Python code calculated the accessibility score for each block based on those calculations, based on the travel time and distance calculations. And at the end, we used the accessibility score for each block to, in a GIS software, to create visualizations and compare accessibility over the region. If you need assistance replicating this study, please contact us at East West Gateway Council of Government. I am personally happy to help you if you need assistance with coding or any other thing in my free time. Thanks.
Thanks very much, Amir.